Welcome to clickmyproject.com. Our project title is a trust management system for securing data plan of ad hoc networks. Abstract. The rapidly developing ad hoc network technology has a wide range of applications such as vehicular ad hoc networks, wireless sensor networks, and emergency and military communications. Due to the characteristics such as openness and dynamic topology, ad hoc networks suffer from various attacks in the data plan. Even worse, some attacks can subvert or bypass the frequently used identity-based security mechanisms. To secure the data plan of ad hoc networks, we propose a novel trust management system. In the system, fuzzy logic is exploited to formulate empirical knowledge which is used to evaluate the path trust value. Together with fuzzy logic, graph theory is adapted to build a novel trust model for calculating the no trust value. To defend against increasing attack to trust management systems such as slandering and harboring, we propose a filtering algorithm. An efficient trustworthiness decay method is also designed to resolve the conflict about the decaying historical trust value in a trust-based routing decisions. Additionally, we present a feasible trust factor collection approach to assure that the trust management system is compatible with other security primitives such as encryption and encapsulation. Finally, we implement the proposed trust management system by integrating it into the optimized link state routing protocol. Simulation results show that the proposed trust management system works well in detecting and resisting data plan attacks. Let us see the flow of our project. First, we have to form wireless ad hoc networks. Then, in our project, we have to form the random mobility model between 30 nodes. If malicious nodes are interrupted, we have to analyze the trust factor collection using cryptographic security functions. That malicious are nothing but the data plan attacks, Sybil attacks, black hole attacks, and gray hole attacks. The malicious nodes are steal the information from the user, which may bypass or deleting the valuable information from the user. If the malicious nodes are identified, we have to implement trust using FGP based OLSR protocol. If malicious nodes are identified, we have to identify these malicious nodes and we have to send the data to another node and transmission is done. Also, these malicious nodes are fully deleted from our network. Then we have to analyze our project into simulation. From that, we have to compare our system with the existing system. From the simulation result, our proposed trust management system provides better trust management scheme and throughput as well. Let us see the output of our project. First, open the VMware workstation. In that, we have to click this terminal window and change the directory for our project folder. So for that, we have to type cd space our product code folder name. So change the directory for our code, cd space code. Then this is important for running our TCL file. That is, this is the syntax for running our TCL file. So, ns space main.tcl. So when we enter this, it will produce number of nodes set in our network and a trust management scheme. This trust management scheme is started from the node starting time, that is 0, to the node end time, that is 30 seconds. So in our project we use security functions such as cryptographic functions, and for trust calculation for each and every node we use trust management scheme. Our proposed system is implemented by using OLSR protocol, which is based on fuzzy based graph theory OLSR protocol. So it is finished at now. This is in 15 seconds. This is finished at 30 seconds. Once it finished its execution, it will produce one file called the NAM file. The NAM window is nothing but network animator window, which contains our simulation video. So this trust management scheme shows our normal leaving, abnormal leaving, normal joining, abnormal joining, and higher bandwidth, lower bandwidth of each and every node at each and every seconds. This updated time is nothing but each time for the node taken, the time for transmission. So now the time is 20 seconds. If it come from 30 seconds, it will start our NAM window. So now this is in 21 seconds. So our project we use three concepts, that is fuzzy logic, trust management scheme, and FGT OLSR protocol. So our FGT OLSR protocol implement the trust management scheme, then the existing system and the throughput as well. So now the time is 25 seconds. Once it finish, now it finished, and it will generate our NAM window. This is our output window called a network animator window. When we click on this play forward button, it will works. So our network contains 50 nodes. So we have the choice for speed up the simulation. So this is for speed up the simulation process. This is our source node and this is our destination node. If we want to zoom this process, just click this icon, and this is for source node and this is for destination node. So our process is dynamic manner. So if when we run this project in one time, it will produce our source and destination nodes in this manner. When we run this another time, it will show in somewhere. So when we click on this, so all nodes are in random mobility model. All the nodes are in a slight movement. Now the transmission is done. This is our transmission phase. These round circles are nothing but beacon messages. That is, this is our CTS, RTS and acknowledgement message, and this is our TCP communication. So all the communication is done via this transmission control protocol. Time and the number of packets sent at a time is shown here. This is CTS. This round circle denotes the CTS. There is nothing but clear to send, and this round circles are RTS and the acknowledgement. So these gray nodes are nothing but the attacker node. So our process is we have to identify this attacker node and we have to block list from the network. So now all the networks are blacklisted and the data transmission is done without any interruption. So now the data transmission is done via this neighbor node 36. All the routing table informations are shown in the terminal. So this does not interfere our data transmission. So now also the data transmission is higher bytes, that is our throughput is higher than if any malicious nodes are occurred, that is identified by using our trust management scheme, and that is blacklisted from our network. So for running our simulation result, just close it and type xgraph. Our simulation result will shown on a xgraph. So for that we have to type this syntax xgraph space thr.xg. thr is nothing but our throughput calculation. For typing this, it will produce our xg graph for our output. This is taken from the trace file of our NAM window. So this is our throughput calculation xgraph. Thanks for watching.